Hello there, good evening everyone. This is Dari on WorldStreams Radio. Thank you to everyone all around the world for joining us tonight. To learn more about WorldStreams Radio, visit our website, worldstreams.org. You can also find us now on Facebook at facebook.com/WorldStreams. Our guest tonight is Sonia Shah. Sonia Shah is an investigative journalist and author of critically acclaimed and prize-winning books on science, human rights, and international politics. Her latest book, The Fever, How Malaria Has Ruled Humankind for 5,000 Years, is based on 5 years of original reportage in Cameroon, Malawi, Panama, and elsewhere. Her 2004 book, Crude, The Story of Oil, 7 Stories, was described as brilliant and beautifully written by The Guardian and required reading by The Nation. Her raw, powerful 1997 collection, Dragon Ladies, Asian American Feminists Breathe Fire, still in print after more than 10 years, continues to be required reading at colleges and universities across the country. Hi there, Saeed. Hello and welcome, Sonia. It's a pleasure to have you with us tonight.
Thanks for having me.
Well, hello, Dari. Good evening, everyone. Thank you for joining us, and good evening to you, Sonia. Thank you for being with us tonight. Hopefully, we'll get a chance to discuss as many ideas from the fever, how malaria has ruled humankind for 500,000 years, also the body hunters and crude. Let's start with the fever. What made you decide to write a book about malaria?
Well, it's a disease that's always interested me. It's a very, very old disease, and that's something that I found quite interesting because we've had malaria probably since we evolved as humankind, and we've known how to treat it with effective drugs for hundreds of years. We've also known how to prevent it for over 100 years, and yet we still have 300 million people getting sick with this disease every year, and nearly 1 million people die. And so the usual idea when you have a disease that you can't control is that there's some failure of technology. But in fact, we know how to prevent and cure this disease, and yet we still have a huge burden. So I wanted to write this book to try to figure out why that was.
And obviously, everything is the insect that's responsible for everything is a mosquito, right?
That's right. The malaria parasite is carried from person to person through the bite of a mosquito, and it's actually not very many species of mosquitoes carry malaria. Most people don't know that, but only mosquitoes from the genus Anopheles actually can carry malaria, and of those Anopheles mosquitoes, only probably about a dozen species of mosquitoes transmit most of the world's malaria.
So what makes a mosquito predisposed to be a carrier than another mosquito? Is it very much a natural selection, a Darwinian natural selection of some sort?
That's a really fascinating question, and I don't think there's any solid answers. I mean, we know that most mosquitoes will fight off the malaria parasite. They consider it an intruder in their bodies, just like we do. So their immune systems will, instinctively kick in and fight off the parasite. Most of them do that successfully. So these carriers of malaria, these particular species of mosquitoes, for some reason, have a less robust immune response to the malaria parasite. They still do have an immune response to it, so they are trying to get rid of it on some level, but it's not enough. And why that is still a very live question among mosquito biologists.
Well, obviously, the other live question would be, how does a mosquito get rid of the parasite? Do we know how the mosquito gets rid of it?
I think there is there is some knowledge about that, and from my understanding, mosquitoes bombard it with chemicals and encapsulate the parasite in what could be called scabs. And that's effective. Now, what the parasite does to overcome the mosquito's immune response is to basically just overwhelm it with numbers. So it goes through this sort of regeneration, sexual reproduction that it does inside the mosquito's body, and actually, ends up regenerating to many, many times over. So there's huge armies of the parasite inside the mosquito, and it becomes just more trouble than it's worth to fight it off, because in the end, the parasite doesn't necessarily make the mosquito sick. It doesn't debilitate the mosquito in any really clear way. I mean, there's certainly some effects it has, but a mosquito that's infected with malaria will still be able to reproduce freely and pass on its genes. So there's no sort of natural selection at work against mosquitoes that are infected with malaria.
So this virus, the mosquito actually does not by itself make a person sick. It is the virus that it sends into the body, correct?
That's right. So the malaria parasite, and it's actually more complex than a virus. It's actually a protozoan little microbe, and it lives inside the mosquito for half of its life cycle, and then it waits on the salivary gland of the mosquito. So when the mosquito bites a person or any other creature that has blood that the mosquito wants to use for its young, that's why mosquitoes take blood meals to nourish the eggs of their young. When they do that, they drop in a few drops of saliva on the site of the wound, and that is sort of to anesthetize the spot so people don't feel the piercing as much. The saliva also has some anti-clotting agents in it. Anyway, the parasite is waiting there on the salivary gland, and so the parasite drops out with the mosquito's spit, basically, and thereby gets access into the wound, into the next host. So half its life is in the mosquito, and then the other half of its life is in the whatever creature the mosquito is biting to get its blood meal. And it could be humans, it could be birds, it could be any number of other creatures.
Okay, so here is a mosquito that drops this parasite. Obviously, there is a difference between the word parasite and virus. You just said that parasite has more complex ways of, of existing in a mosquito than a virus, and also behavior. Now, the parasite goes through a long journey that turns out to be a cycle. Could you explain to us how that works?
Well, the parasite, once it comes into our body, it hides in our liver for a while, and that's part of probably its evasion tactics to get away from our immune system. And inside the liver, it regenerates for a while, and then it comes out of the liver. The parasites come out of the liver, and what they want to do is invade our red blood cells. And that's really what they're after, is the hemoglobin inside of our red blood cells. So that's what the parasite feasts on. They eat that. That's their nourishment. After they've finished eating all the hemoglobin and it's all completely gone, the cell will rupture, and the parasites will burst out of the red blood cells that have now been destroyed. And that's when people will start feeling sick, only at that time. And the parasites will then infect a whole other generation of red blood cells. So the cycle goes on and on like that.
So this parasite has something in common with the mosquito. The mosquito also is hungry, has an appetite for hemoglobin, right?
Absolutely. So they're both after the same thing. In the case of the mosquito, hemoglobin, our blood is not food for the mosquito. The female mosquito takes blood from us only when she's about to lay eggs. So it's only to nourish her young so that she can she can lay the eggs of the next generation. She's not doing it for food. For food, they get nectar, they get other things from plants mostly. For the parasite, the malaria parasite, they need the hemoglobin to survive. That is for them themselves to survive. That is their nourishment.